moisture can turn the oil acidic. So if you've ever had oil that's open for a long time and you smell it and you're like, man, that smells funny. And it's not all oils that do that, but it can happen. But the other one is, I believe there's some combustion byproducts that can be a little bit acidic as well. So, and maybe acids is too strong of a word where it sounds like somebody dumped acid in. Maybe think more pH went to the acid side of the scale, is my understanding. So you got all these added chemicals and combustion and moisture, and it can go to the acidic side of the scale is probably a better way to phrase that. And then carbon and metallic particles, hopefully those get caught up in our filter, but if they're really tiny, we're going to talk about the spectroanalysis here later, they'll still be rolling through your system. So all those contaminants are contaminants, and that's one reason we like to change our oil, not just based on hours flown, but if you read the MO or some of the other manuals, they'll say, hey, even if you're not flying this thing every 4 months or once a year, depending on the engine manufacturer. I was just reading one the other day that said you should change the oil every 4 months, no matter how many hours you fly it. And I was like, oh, that's interesting. And part of it is these. If you run an engine, they actually want you to run it for, well, they want you to get it hot, but like basically an hour to help get the moisture back out. So if you have an aircraft that's sitting all winter and you're like, you know what, I should run this every once in a while. If you don't get it hot enough, if you don't run it a good 45 minutes, hour, sometimes it can be worse on it because the moisture, when we say moisture, some of that is, you know, when you start your car up and you got all the steam coming out the backside from you burn fuel, and that turns into CO2 and H2O coming out your exhaust pipe is a big part of it. Carbon monoxide is when we're incomplete combustion. But so get it nice and hot and let that oil be nice and hot for a while. That can help us get the moisture out of the oil. There was a word we used in hydraulics class. I don't remember it right now. It's not phobic because that's afraid of water. Somebody, I'll come back after break with it. But it means the oil likes to absorb water. That's a problem we have with our oils, especially in refrigeration, but that's not this case.
Is it hydrophilic?
Hydro what?
Philic?
Could be. Is that what you're online saying?
I was trying to steal it.
Yeah, it would be oil that likes to absorb water. Hydrophilic. Okay. Hydrophils it. Hydrophilic. I'll go with that. All right. Anybody see the date on this thing from where you're at? 1970. I didn't know they were high tech enough back in 1970. Well, I mean, they went to the moon sometime around there, right? So back in 1971, you've got this service letter about spectroanalysis, graphing your oil and send it in and have them test your oil. And I'm like, wow, I thought we were so much higher tech than those guys. But apparently not so much. So they actually recommended way back there doing this. That's 45 years ago. That's almost half a century ago. Spectroanalysis on your oil. So this talks about, I think I pulled this off the oil sample tube. They all have their own sampling, right? But in general, we talked about this a little bit. Anytime you're wondering if something's going on, but if you want to sample it regularly, operate the engine until the oil temperature stabilizes, shut it down, basically see how much oil's in your engine. Take the sample at the time of oil change, but if this is not convenient, the oil may be sampled anytime after it has been in the engine for 10 hours operating time. So they're saying, don't take an oil sample after you only put it in for 1 hour. Now that said, some of these were like, switch your oil out after 5 hours if we suspect damage. Well, you might have to tell the people what's going on then. The oil sample must be clean. Be sure the area around the drain, so that means before you pull the plug, wipe the drain off. Filter tube is perfectly clean before it's taken. If the sample is taken out when the oil is drained, let half of the oil run out. Then take the sample by holding the sample bottle in the oil stream. So it's basically saying start draining your oil. As it's draining, you take your little sample thing, put it in the oil waterfall that's coming out, oil fall, and then pull it back out. So they don't want the first bit, they don't want the last bit, they want the middle bit of oil as you're doing a sample. I threw this video in here, but we're not gonna watch it because it is incredibly boring. If you're into science and stuff, it's kind of cool, but yeah, I can't handle this one. So if you want to watch it in your own time, it gives you a pretty good idea of one of the ways that they can check your oil. It's a little bit different than this. Is this spectrum? They start changing the letters on me. Maybe if it wasn't so boring, I'd watch it and I'd understand. But it's one oil analysis, inductively coupled plasma spectroscopy. I believe it's the exact same thing as what they were doing back here in 1971, pretty close to it. But anyway.
Good day, everyone.
This is what we do need to know, though, because if you do that analysis, we're going to have these potential things that are going to show up, and they're going to say, hey, you've got this material in your oil. So instead of being bored with me through 2 lectures today, we're going to go around the room, and we're going to try to give it entertaining read. We'll even pull the old name jar out. If you say pass, I guess we'll let you pass, but we're all gonna boo you. So if you say pass, everybody give a good boo, and then we'll go on to the next one. Oh, she's taking tests. Boo. Yeah. All right, Parker, you're up with iron.
Where from rings, shafts, gears, valve, drain, cylinder walls, and pistons.
They've got a little quiet towards the end there, Parker, but okay, not too bad. So iron, yeah, a lot of times rings, yeah, it's a lot of stuff, right? Okay. All right, Steven, can you improve on his fading? So go ahead and read our chromium one if you would.
Primary sources are chrome shards, such as rings, liners, etc., and some coolant.
Coolant additives. Well, that would be if you have like a liquid cooled engine maybe. Interesting. So we're not gonna have a lot of chromium. It's probably gonna be our chrome line cylinders. We got a chrome line cylinder, right? Charlie, can you do nickel for us? Did I hear a pass? Or is he thinking? Might be hard to see from your side.
Secondary indicator of wear from.
That one's certain. I realize it's certain. Yeah.
Types of bearings, shafts, valves, and valve guides.
Alright, cool. And you might say, why are we reading through these case? And I go, well, it shows up kind of on some questions. But they want you to kind of know. Ryan, hopefully in his class, as you were going through these parts, kind of touch base on what some of these components are made out of, but you know, this is my only chance to get you guys to do these. So must have grabbed all the people that were around. Brian Erdy in your best radio voice.
Lead mostly used from tetrahedral lead contamination.
Tetra what?
Aluminum.
Tetraethyl? Tetraethyl? What's tetraethyl lead? Where do we have tetraethyl lead in our engine? Fuel, sorry, he said fuel. Good, alright. We missed aluminum, but hopefully Josiah will clear that one up for us.
Indicates wear of pistons, rod bearings, and certain types of bushings.
Okay. Rod bearings. Okay. Gavin, could you do copper for us?
That one's really long. I think I'm gonna pass on that.
Micah, help us out with copper.
Wear from bearings, rocker arm bushings, wrist pin bushings, thrust washers, and other bronze or brass parts, and oil additives
nicely done. Oh, who gets the easy one? Zach Kuvar.
Where from there?
I don't know if his heart was really into that. I'm not sure his heart was into that one. I just texted a supporter guy that is really nice, and I just said, hey, thanks for sending me a correction on your support, and he sent me a video of him singing a Three Doors Down at a karaoke in a bar, and that's a tough one to sing at a bar, especially for a guy that's part of AA. So I'm gonna follow up on him, but he was trying. I mean, he was even, so, put some heart into this, like the guy, Tim P, help us out with silver.
Wear bearings that contain silver and in some instances, a secondary indicator of oil cooler problems.
Why in the world might it be oil cooler problems? Any guesses on that? I always thought this was not plated. Think oil cooler. Kind of, you'd say what they're made out of, but
Silver solder.
silver solder. Yeah, those oil coolers that you'd say welded together, but there's a lot of joints all welded. So your silver solder and your oil cooler. So that was always a surprising one to me. Like, oh yeah, that makes sense. Oh hey, nice job. Corbin Robinson, can you do titanium?
Alloy and high quality steel for years and bearings.
Well, don't expect a job at SMAC. Lead and Ouden. We'll let you tell us what that is.
It's probably bendo, and it's gear or ring wear, and it's used as an additive in some oils.
I have no idea. So, apparently if Molly Bendham shows up, your gears or rings. Or some oil. Oh, hey, last but not least, Dan Wilson. Ziegelbauer.
Anti-rust agents, spark plugs, and combustion chamber deposits.
Yeah, but so anyway, gives you an idea of those. Kind of back to, you should just read the chapters when you get a chance, so now you can skip that section in your chapter. But, yeah, some of the different areas that they come from. Your textbooks are approved data, I believe is the word they used, right? But what is acceptable data, sorry. What is more, what's gonna be what you're gonna follow, your textbook or the engine manufacturer? Engine manufacturer, yeah. So the textbook does tell us stuff, it gives us a lot of advice, and then the engine manufacturer often gives us some other. I found this one prepping the class, it's pretty interesting. It does say operators can choose your appropriate oil to service your engine. Viscosity brand, your preference, not a big deal. Here's where we're at. Analysis indicates consistent servicing with one brand of oil will result in fewer maintenance events and more consistent oil analysis results. They're just giving us info. Continue using the same oil brand throughout the service life of the engine. Do not change from an established oil type. So back from mineral oil, semi-synthetic, even within the selected brand before engine overhaul. And I'm like, it doesn't say shall, it doesn't say must, but it also switched from advisory to it says continue using. So I'm not a big fan of that little statement in the MO for Continental because, for instance, I have to turn the recording on. In our float plane, I think they were using the red. What was the red one again? I'm going to double check myself. Aeroshell, that's right. I should have gone to more air shows, so I would have had that memorized, right? The fancy smoky planes. We were using Aeroshell, and at some point we have switched over to Phillips, and you go, is that allowed? We did it before. I mean, when you read that, I believe this is a little bit more in the advisory nature, but, I mean, it's pretty clear, continue using the same oil brand throughout the service life. So that's interesting. We're bringing the plane down to MMS Friday, and they're gonna switch from the one that has the lycoming additive, I believe that's Victory oil, right? Victory is what we've been, I think, putting through there. And I think they're switching to just the XC. Difference is no additive. Now this is within the same brand, but so it gets a little funny. The big thing I would say to point out is if you can, you stick with the same oil, have a really good reason for switching, and then if you switch, probably want to do your first or second oil change quite a bit earlier. Oh yeah, I saw a hand over here.
So it says don't change from mineral oil to synthetic oil.
Yeah, so they don't want you to go.
Does that not count then for break-in?
So that's gonna be more following the break-in instructions, and I guess you'd say up above or maybe below. It'll say use this oil for break-in and then switch to whatever one you want. What they don't want you to do is then switch back and forth and back and forth. But yeah, great question. Yeah, so you get a little bit of a mixed signal on some of these, but the main point is you should be very weary of switching around. That can be tricky if you land at an FBO, they don't have your brand of oil. What do I do? Do I run it low on oil or do I add the wrong brand? You know, but just know it's a bad thing. Shame on you for switching oil. And beyond that, to just try to avoid it. In your books, if you want to jot down a quick note, it'll talk about it on page 6-17. So if you want the FAA's version, you can go to 617, but yeah. Already talked about this one, but I want to do it just one more time because we always get, for a couple of them, do I put oil on the O-ring, do I not put oil on the O-ring, is read the filter on that one. All right, we talked a little bit about that lycoming additive and why it came about. So I got a little video for you that shows the actual problem all zoomed in real nice.
What makes someone's work a work of art?
Art takes countless ideas
Obsession over the finest details.
and endless tweaks.
Art inspires fresh thinking.
When you're looking at an airplane, it's important to look at how many hours are on the engine, in this case 700 hours. But the overall had been done 23 years ago. And as you can see from the cam and the tappet bodies here, the stridations you see is spalling, and they would destroy themselves in about another 100 hours of operation. So the owner of this airplane, who's just buying it, opted to have the engine torn down and be completely overhauled with 4 new Lycon port and polished and Aladyne cylinders for the 160 horsepower. So it would be a nice airplane when he finally gets it home, but this is what you're looking for when you pull the cylinder and you're looking for spalling on the cam and tappet bodies. Hope you found this useful and informative. Thanks for watching.
I'm not 100% sure how much I trust this guy, because I don't know him very well. But he said in another 100 hours, he figured they were going to have some engine or valve failure because those were bad enough. And I was like, really? I didn't know if they looked that bad to me. But so that's the reason for the next bunch of slides we got with the lycoming additives. But yeah, we start scraping away on our tappets and lifters. one's talking about adding the agent, the oil, to all these ones. So on some of them, they are actual ADs. And basically, at the next engine change, but no more than 50 hours later, it's talking add the Lycoming added to it. Did you hear on that video, I think I skipped over, but I was gonna say something. Only 700 hours on the engine, but it was overhauled, how long ago? 24 years ago? This guy doesn't fly a whole lot, does he? I would say actually that's probably pretty common in the recreational world. You divide that out, you're 25 to 50 hours a year. So a lot of people don't fly a whole lot more than that. It'd be cheaper to rent your own airplane, but and you can't fly it whenever you want. All right, mandatory service bulletin, you're gonna see all those same numbers up there on the mandatory ones. That one's service instruction. And that's the one that's approving the additive, because there were other parts that say, are you allowed to just put whatever additive in? You know, you're like, man, I love STP and I'm just gonna add that to my oil. Continental's pretty specific on don't add anything to your oil, because what you add, we haven't tested, and we gotta certify your engine's gonna keep working. So you gotta be very careful to only use the additives that are approved. So here's the service instruction saying, yep, this additive is approved. We talked about how sometimes on the oil cans, it'll give you the actual part number of what you're adding. Sometimes it'll give you this service instruction number, 1014N. So if you were looking at the back of the jar, sometimes it'll say in accordance with 1014N, sometimes it'll say it has that part number in. Yeah. Anyway, okay, let's move on. I had to share that, so if you guys got out of here and didn't know all about that, you show up at FBO, they think bad things about SNAP, so definitely gotta keep that one in here. Okay. I think there was something I was supposed to read in here. Point number 3 especially. When you're switching from non-dispersant mineral oil, so like your break-in oil, to your ashless dispersant oil, so your good stuff, you're gonna do a bunch of stuff. One of them is check all oil filters and screens for evidence of sludge or plugging. Change oil every 10 hours if sludge conditions are evident. Repeat 10-hour checks until clean filters and screens are noted, then change oil at recommended intervals. So when we're changing from our break-in oil or our mineral oil to our ashless dispersant, they are really sensitive to, let's watch this really, really close. And it's because they'll tend to loosen sludge deposits, and then those sludge deposits will cause clogged oil passages. So just be super careful when you're switching brands. Here is a Blackstone report from one of our students last year. Now, when you're reading these from Blackstone, and they're probably the leading, as far as I know, leading analysis. You're reading the older ones are over here. The dates 2020. It's June 2022, August 2022, October 2022. So you're going from oldest to newest on the left-hand side. That's funny. I blocked off the client, but it still says Stan. So this is Stan's airplane. So they'll actually give you a little commentary about what they saw in there, because we probably don't know how to read them. So who can tell me, I know it's a little bit hard to read, but when did he switch oils? He switched from a multi-viscosity to a straight weight. Anybody? In the back, is it too hard to read? Yeah, so right here. So between August and October, and you'll notice on some of these numbers, we went on the phosphorus from being 1100, 1100, and then 248, 92, 79. It just dropped a ton. If we go up a little higher, we've got our copper went from 42.37, and then it drops to 2014.13. The unit location averages here, that's kind of my understanding. Nope, I'm the wrong way. This is his averages. This one is averages of all airplanes. So that allows you to kind of look and be like, hey, before he switched, he was up in the 30s or 40s, but most airplanes are only running at 9. And you're like, whoa, why am I so much higher? Well, part of it was just his different oil he's using, because once he switched over, he was a bit lower. He comes down closer to the copper. That one that we watched on the video, they talked about silicon was very high, right? Can I find silicon on here? Here's silicon. 6, 6, 4, 2, 5, 6, 10. So he doesn't have as high silicon. So the guys that really know what they're looking for, they'll be able to pull out some of that stuff that may or may not affect all the other numbers. Some of the big ones that went up are his calcium went from basically nothing to it popped up quite a ways. So I would look at this and say, I have no idea what any of that means. Just, you know, I don't know. I'm gonna come up to this section and say, Stan, here's another clean report. Wear metal's held pretty steady, so mechanical parts are getting along just fine from what we can see. The flashpoint test didn't reveal any fuel and no water showed up. The air and oil filters weren't anywhere near being used up, since silicon and insolubles were nice and low, basically saying it's not passing through your system. It looks like this IO 540 is going to fill the page with mark-free reports in no time. So even though I'm looking at, man, his numbers jumped around, oh, are these bad? The guys that really know what they're talking about, they're gonna give you a pat on the back. If they don't give you a pat on the back, they'll say, whoa, you better look out, go check this in your engine. So anyway. Oh, I blew it up. Why didn't I do that on the last one? There you go. You get some numbers moving around. We already know it's got a clean bill of health, but yeah, just changing. I think what I said was from a let me get it back. Switch from multi to straight weight. So switching from multi to straight weight changed a little bit of, you know, less of those multi-viscosity additives. So interesting. All right. Oh man, that's it. That's the whole slideshow. Let's take a break. Let's I gotta get geared back up for the next one. Let's make it a 12-minute break. So come back at 8 o'clock. And we'll launch into lecture 2, which is a little more fun. That's part of why I want to do 2 today. This one's boring. Oil tests. How do you make that a second? Oil tests. Oil analysis. Say what? Played a little Halo. We used to carry around the real TVs, you know, the ones that are this thick. We put one in the back of our car that was just barely big enough where you shouldn't have carried it on your own. We'd have Halo parties with 2, 3 TVs.
LAN parties?
Yeah, the first Halo.
Did LAN parties?
I don't think they were LAN, because with Xbox, how was that working? Did we each have our own TV? No, we shared. We have a top and a bottom.
Oh, you were doing flip screens?
Yeah. Well, I don't think that was LAN. Was it LAN?
Split screen, like locals, like on the
Well,
same screen?
that'd be local.
We'd be teams, so like we have 2 guys on one team,
Okay,
and
so
they'd
that
be
would be,
teammates.
yeah, if you're playing with other people online, like the same network,
Yeah.
that's it.
Well, it's not online, right? Like you're all hooked up in the
I
same.
guess it is
Yeah.
a LAN party. Yeah, local, yeah.
Local area network or whatever.
Yeah, that was fun.
That was like my favorite thing to do. I love it.
Your split screen campaign.
Well, and then you like get in a fight with your brother because he thinks you're screen vegan.
Yeah.
No screen vegan.
Which Halo did you play?
I
funny, cause, Zach watched those guys try a bunch and it wouldn't go. So he got it in there and just really put the accelerator pump to it. And it actually started, but he said it ran terrible. And then they came back and they couldn't get it to go, and then he couldn't get it to go. We're guessing we got lucky and we got it to pop once on the right mag. And then once it was up to speed, the right mag might have sustained it.
Okay. Thank you, sir. Yep.
Alright, this'll be a better one. lubrication?
I was like, yeah, I did have internal struggles with that for sure.
Supposed to be rainy today. I think I heard a piece of thunder or something.
Yeah, yeah, so probably not much now, but John, what did you do with your hair?
I didn't do anything to it. Did something cool enough.
With it?
A barber.
Just gonna get a barber.
See the barber. Oh, wow, I should get one.
He has an old, like a little costume, red and white stripes as well.
We got Susie. Do you do a barbershop songs too?
If you bring a speaker, we can set something up.
Alright, but. I got a speaker in my car.
Yeah. Timmy's Barbershop. Timmy's Barbershop.
What makes someone's work a work of art?
Art takes countless ideas.
So here we have this area here. That
Unless you get a barber license, it's just not worth it. Takes too much work to get.
You have to get barber's license.
Oh yeah. You can.
Jeez.
If you don't want to make money legally.
Legal.
You can always make money. Medical efficiency.
I could just do it.
But
Work in my law.
I cut my hair.
You look like you could be a barber, actually. You got that kind of. Dude, you'd be a pretty awesome barber.
Yeah, dude,
It takes
you could
2
charge
years
so
to
much.
get, and it doesn't pay very well on the backside, so.
no, you could get so much money if you buy a plane and you could say home,
No.
home cuts. Timmy's home cuts.
That sounds like butcher shop, dude.
That'd be sweet.
Yeah.
Once a
Butcher
barber
and
chair
butcher.
in the back of a helicopter.
Yeah.
Like hop in the helicopter.
Timmy,
There is
not
a
ideas.
hair all over the inside of this helicopter.
Dude, if you're getting paid, you charge so much. You have to charge so much.
Like what? Be like
Be
$2,000
like
haircut.
$1 per hair.
Yeah. There are so many people that would do that. They
Oh,
might be onto something, because then when you show up at school the next day, and they're like, "You get your hair cut?" And you're like, "In a helicopter." Crazy story.
You got $2,000?
Yeah. There's people that
I did at some point in my life.
before going here.
I imagine that's about what I'd have to charge you.
Shortly after.
I mean, if we, yeah, if you wanted to be big enough to actually set a barber chair in the back, probably.
Yeah, dude, that'd be crazy. A whole shop, like six barber chairs in the back.
Hey, you
our second lecture of the day. This one will be a lot more fun. There is a 6-minute video that is, the guy is just boring. He's just boring. He's teaching about labyrinth seals, which are anything but boring, but he's a little bit dry. So we're gonna try to put a joke on the front end, a little story, I should say. I don't wanna give away the joke. But I was talking to Trevor the other day, he's in the story now, about restaurants. My family, at least my mom's side, we love our restaurants. So he was asking me about the blueberry cobbler. He was like, doesn't that taste like home cooking? We don't like home cooking in my house. We like restaurant cooking, because we go to good restaurants, it's better cooking. So anyway, I was at a really nice restaurant, and our waiter he was a big guy, hefty. He was a large fella, he was a big dude. And my wife clearly was not gonna finish her burger. She's like half done. And the guy comes up and he says, you want a box for leftovers? I looked at him, and I was like, nah, you can have it. I'd get my butt kicked. Yeah, you want a box. Yeah, alright. So, one of the cool parts of joining mission organizations, especially cool in like Samaritan Aviation, I get it twice today, this is fun, is the cool people you get to meet. This is hanging out at the floatplane base. If you didn't make it to the floatplane base, shame on you. It's, not shame, too bad for you, it's so fun. This was, I think this was 2 years ago, but this was the air show crew. So we sat in the room with the guys from the F-35 and 22s and Patty Wagstaff and the other dude that flies the one with lights on it. And it was fun. So we're in the back of the room. This crew, yeah, a bunch of yahoos, right? But this guy runs kind of the floatplane base, so he's a fun dude. He's kind of like an uncle to me. This guy flies the super heavy FedEx planes out of Canada, if I'm not mistaken. So he's like legit big time hauler. And I think this guy is American Airlines. And if I'm not mistaken, these two fly the little multi-engine, complex, instrument-rated, fabric-covered thing. Yeah, it's a wild. Aircam, that's what it is. So anyway, it's a weird crew, but you get to meet some pretty cool people. Here's one of my, I think I blocked his name off. One of my supporters that I had never met. He's from Texas. He knows people I know, and started supporting our family. And I'm at the air show, and he's like, hey, I flew Fifi in if you want to come get a tour. I'm like, I'll take a tour of Fifi. So the first time I met him, this is the guy that supports us monthly, continues to still. First time I met him was at the air show, and I got to sit up in the front of Fifi, which is a B something. I don't even know my numbers. 52. B-52? Isn't the 52 the ones with like jet engines? B-29. B-29. Yeah, you're making it up too. You're just throwing it. B-29. Anyway, it was really cool. Yeah. But super nice guy. His wife was there one year, and I said, hey, thank you for supporting us, and he got all funny. I don't even know if she knows she supports us. So I mean, he wasn't that funny, but just some of the cool people you get to meet. We get our tent at Samaritan where we hang out, and just rubbing shoulders with people in there. We got our cook. This guy runs a flight school out of North Carolina, and he comes up to Oshkosh every week to cook brisket, pork loins, and stuff for us. This guy here is our board director. He's an ER doctor. That's his wife, and they're out there every week making sure we're fed. How else do I get to meet people that are like ER doctors, board directors? There's Cranston again. And Joey Burns is a ranch salesman. He sells like those couple thousand-acre ranches out west of people. It's like kind of cool, right? Jason Schwitters owns a couple thousand acres. He farms sugar, so keep eating sugars, because he's a big sugar guy. He also does beans for Korea. I don't know, kind of a weird niche market. But so he's a dude that lives in Wisconsin, and I never would have met him otherwise. And it's kind of like Uncle Jason now. Every time I see him, biggest smile. What's interesting with these guys is they care so deeply for the staff. Now, whether it's Samaritan or other organizations, you'll meet people that are the same way. These guys, maybe they could, but I mean, ER doctor, ranch salesman, couple thousand. These guys can't move to Papua New Guinea without really like getting weird. But they live, we use the word vicariously through us, and they're happy to do it. So people that support the organization support us in some instances. Just some of the most amazing people you meet. Rex, I put on there, is a family counselor, so he's got a family counseling practice. He is one of our guys that checks in with our staff members. I don't know if it's monthly or quarterly now, but just to talk to the husband and wife, because you know, if you're married, you know. So he checks in with you, see how you're doing, see if he can help be a third party in, you know, arguments. Did you get pizza or did you get hamburgers this week? How come you got pizza? You got pizza every week for the last 3 weeks. Why don't you do what your wife wants, Case? Stuff, you know, stuff like that, just to help you get along. But it was a big blessing to serve them. And this was supposed to be on your last day, and this is your confidential application for Samaritan Aviation. So if anybody's serious, don't say we didn't invite you. Come ask me. You won't find them online. You got to get the applications from me or somebody in the office. If you don't like me, that's okay. You can get one from somebody in the office. But we're going to have a conversation about where you're at. Are you going to church? Are you involved in church? Stuff like that. Because we want people that want to be missionary mechanics, missionary pilots that want to serve God through it. So anyway, that's the last you'll hear about Samaritan Aviation, probably for the rest of the year. So sad. Into the real lecture. Bearings. We watched Agent JZ talk about bearings, showed us some bearings. It was pretty cool. We got them all over the place. We do not want the oil that's in our bearings to get in the combustion chambers or leave our engine. So we got some pretty fancy seals in our engines. So this just gives you, we got a roller bearing, we got a ball bearing that's going to handle some thrust, another roller bearing. Just shows you some ideas of where they might be at. Interesting question. Is this bearing here up front, what's it doing? Who can tell me, what's that bearing, what kind of loads are on it? Is that right? Not if it's a roller bearing. Yeah, all that guy's doing is trying to hold the fans so they don't go up or they don't go down. A roller bearing is not going to have a forward-backward motion. Same thing with this back one. So on this particular, it might be a made-up jet engine, I'll give you that. But pretty common on this particular one, they only actually have one bearing in there that's dealing with the thrust in here. And it's like, what? Huh? So you start thinking about it, and you're like, well, aren't all these blades, like, isn't that whole shaft going to try to leave the front of your engine? In case it doesn't look like you got enough bearings to hold 20,000 pounds of thrust in here or whatever, right? And I did a fair amount of, I went down a lot of rabbit holes trying to figure this slideshow out for you guys. Part of it ends up being, we're going to talk about it later, but a lot of the thrust force is actually not felt on the bearings. So what you can get in your head, if you're like me, is you're picturing all those fan blades like being the propeller that's pulling you through the air. Not exactly. You got to think of it a little bit more like we've got a lot of materials, so you could say pressure, but it's going really fast. So we have a lot of energy coming out the back of our engine, going backwards, which is going to, you know, for every action, there's an equal and opposite reaction. You're going to want to make us go forward. So a lot of the forces on our turbine engines are actually, and this one you notice is a low bypass, it's pretty much a no bypass engine. A lot of the forces are actually felt in the different case sections and on the stator blades as well. So if your rotor blade is trying to push air backwards, your stator blade is, you know, acting opposite. But we'll get that a little bit later. I just wanted to throw in the part of bearings is a lot of them aren't actually holding the loads you might expect them to. Now, this is an oil dampened main bearing. Oil dampened being the key word, it's yellow and red, it will be on your exam. Helps with reducing vibration. Also allows for slight misalignment. So the idea here is the green, if you will, and this is obviously exaggerated, the green is going to be pressurized from our oil system, much the same way that your plane bearings are, like not airplane, P-L-A-I-N, plane bearings, are have oil pressure on them, and your reciprocating engine. So you put oil pressure in here, and as all those things are spinning really fast, this bearing is not designed to hold tremendous loads in that up, down, sideways. It's just supposed to, kind of hold them in the vicinity in that area. So if our shaft is out of alignment, in this case, our shaft is slightly down to this right quadrant. That oil dampen bearing will allow it to basically slide into its alignment position. So yeah, the oil's kind of holding it in place, but part of the dampening part is as you get vibrations on here, if it wants to move around a little bit, the oil will keep it so that you don't have metal on metal going bang, 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 and we're not stressing everything. So oil dampen. What they didn't draw that they probably should have is they probably should have drawn an oil inlet line and oil out, that kind of idea. But yeah, so oiled dampened bearing, kind of cool. Comments, questions, side remarks? Okay. This shows it's supposed to be the same thing from a different view. It's pretty hard to tell what's going on. They give it from the side, so you see the oil coming in and the oil out. Yeah, I mean, it's kind of leaking. It's kind of leaking out of there, right? Because you go back on our turbines, we have dry sump systems typically, right? So you're going to have the oil pressure coming in, and then you're going to have a dry sump that's going to be sucking the oil to get back out of there. So this doesn't give you the complete picture. What they do want you to see is the anti-rotation mechanism. It's kind of like a little keyway that's going through there. It keeps the race from racing. It keeps the outside from running around. And you notice they put it on that one as well, anti-rotation pin. Okay. Yeah, that's big, right? So that's back to Agent Jay-Z's thing of FAA or prep where it likes to say it's the primary purpose of our oil lubrication. Well, on our turbine bearings, yeah, we're cooling the bearings with our oil. One of the huge jobs is cooling. Oh, I found this picture and spent way too much time looking at it, and then after all that, it's still a little bit off. So here's an interesting one. We've got, now again, this is this does not have a bypass on it, so this isn't a airliner engine. If you had a big bypass section, you'd have a tremendous load, like 80% of the load would have to be carried on a thrust bearing up front, right? So this is looking at a non-bypass turbojet, and if you had a bypass, this part would all be very similar, but you'd have a big old thrust bearing up front that's going to carry about 80% of the thrust load on it. So just a FYI. So when you look at this, what they're giving you is they're giving you essentially if you had bolts holding together this section of the engine to this section of the engine to this section of the engine, they're basically saying which direction is that section of the engine trying to go, trying to leave us. So interesting part with that one is it kind of makes sense that the front section is trying to pull us forward through the air, right? Because, well, we got all those compressor blades. You'd say it's trying to suck us forward. Suck us forward doesn't really, I mean, if you ever tried to use a shop vac on a little cart with wheels on it and suck yourself anywhere, you laugh, but because you can use a leaf blower to blow yourself somewhere, right? But it's pretty impossible to suck yourself anywhere. doesn't work. So it's not sucking us forward, it just doesn't work. But what happens is that fan blade is blowing against your stator blade, right? And the stator blade then redirects the air. So this whole section, our compressor section, it is trying to leave the front of our jet engine. And you could say it's dragging the engine at 19,000 pounds away from the rest of the engine. And it kind of makes sense if you think about it, because the whole point of that thing is coming out the backside, we have highly compressed air, right? So even if you just drew a line there and said we went from non-compressed air to compressed air, you could in a snapshot of time say, well, we got some pretty highly pressurized air trying to blow the front off the engine. So that one's pretty easy to get, but you know, kind of interesting yet. So the front of the engine's trying to leave us. The next section, which is our diffuser getting ready to send it into our combustion chamber, that one's also trying to leave the engine. And you go, there's no blades in there. Why is that one trying to leave the engine? You know, well, we went from a high pressure to a lower pressure in our combustion chamber, right? Because in our combustion chamber it expanded, the volume went down. So same kind of idea is that section where we went from the highest pressure into a lower pressure, that one just pressure alone, that's trying to leave our engine out the front too. And then we got the combustion chamber. Would kind of make sense that that one's trying to leave the engine up front because we lit off the flame. And if all you understood about jet engines was you get a flame and it pushes you forward, that would make sense for this section, right? So, yep, that's trying to leave the engine to the front as well. Now, what's interesting is our power turbine, it's actually trying to leave our engine to the back. If you slice that with Luke's lightsaber, Luke Skywalker's name, right? If while this engine was running, you went, yeah! The back of the engine would actually go backwards, which is interesting, right? You'd be like, what? Well, you got all this high pressure, high-speed gas going backwards really, really fast, and it hits your turbine blades. So your turbine blades, there's a tremendous amount of force trying to force your turbine blades in that backwards direction. So what's interesting is that part of the engine, it would actually be trying to go backwards. And then the last part, our nozzle, that one's trying to go backwards. It's like, what in the world is going on here? Well, basically, these shoulders here, right, where we narrow down our gas and reaccelerate it coming out the back, it kind of makes sense that you got all the pressure coming out, and they're holding it in. So they would try to go. So all that to say, that is the sections of your engine and the overall direction that each section would want to go. Why I got there is if we narrowed it down and said, okay, well, what force is on this bearing, and that bearing, it gets a little tricky because this whole section averages out the compressor blades versus the stator blades. And basically what I've been told is, is it the right one? Oh, it just gives you a picture. Turbo fan, we got a bigger fan on the front. What I've been told is at different RPMs, it might actually change a little bit what's on each bearing or that section, because at a higher speed, we're going to be working more on the pressure of the air going through versus the fan blades and turbine blades. I'm looking through where I wrote down. I don't see it right off the top of my head. Maybe it's my next slide. Nope, it's not. So anyway, normally we're going to have one thrust bearing, but that bearing is not going to be holding on, let's say, a 20,000 pound thrust engine. The bearing's not holding 20,000 pounds of thrust. It's going to be a small fraction of that typically. A lot of the other forces are going to be acting on the stators into the case of the engine So it's actually the case of the engine through the stators that's trying to move forward, not just that shaft trying to leave it. So that was mostly what I was trying to get out of that one. Hopefully that was good for you. All right. JZ talked a little bit about our fixed orifice nozzles that just spray oil onto our bearings. We'd say they regulate oil flow to each bearing. If all we had was a pump and pressure, we wouldn't be able to say, well, how much oil do I want here versus here versus here versus here? So our fixed orifices are what we use to regulate how much. So that's just like our carburetors, right? We say our main metering jet regulates the fuel. Well, yeah, all by itself, it kind of does. It works with a couple other things, but it's in yellow and red because I'm pretty sure that shows up on prepware and exam questions. Jumping around a little bit on this one, aren't I? Our tank pressure for our oil is usually going to be not much higher than atmospheric. I think in JZ's video he talked like 2-3 psi is all, which seems really low. I thought it would have been much higher than that, but anyway, so there's that low number, but one of the numbers they want you to remember is if you ever weld a tank, you got to go test that thing at 5 psi pressure. So that would make sense, because if JZ is saying 2-3 psi, you're going to want to test it at probably twice what it's going to hold, right? Oh, I'm sorry.
5 plus the operating.
5 plus the operating, so I'm way off on that one, sorry. 5 plus the operating, so whatever it operates at, add 5, excuse me to that one. So, anyway, might not be as much pressure as you think. We don't want our pumps to cavitate, so that's why sometimes they're pressurized. You guys all did your lab with a magnetic chip detector. And just a reminder, some of them are electrically monitored, some of them not so much. They're just a magnet that you check at various maintenance intervals. So if you get questions on those, look really close to think about, is this electrically monitored? Can I tell what's going on? But as a reminder on those, if we get a little metal particle between the two magnets, between the two electrodes, our ohm meter, or whatever you want to call it, ohm meter, ammeter, whatever they put on there, will say, hey, there's something stuck between us. Let's turn the light on for the pilot. Tell them we got chips. That one prepware question that says a small amount of gray fuzziness is considered normal wear. So remember that, a small amount of gray fuzziness, normal wear. So you got to get up to a certain size before we start carrying. Now, if you can see with the naked eye, those are like grains of sand and metal, you know. It's not just fuzziness, you probably got a problem. But gray fuzziness, you know. Alright, finally made it to the fun part. Labyrinth seals. Now, JZ covered this a little bit. Here's the actual bearing that is holding our shaft so that it doesn't come in contact with our outside stuff, and the outside of the bearing here is connected. So we're going to spray oil onto our bearing to keep it cool, and it lubricates as well. We don't want any of that oil that's trapped inside here to get into our combustion chamber. So what we do is we have an oil chamber around our bearing, and it's not going to be filled up with oil. It's going to be mostly filled up with air, if we can phrase it that way, with an oil spray and oil mist splashing around in there, because we are scavenging out any of the oil that gets in there. We're sucking it out like a shop vac. And you say, well, where does the air come from, Case? I thought you were only spraying oil into there. And I say, yeah, you're right. But we have a labyrinth seal. And basically what a labyrinth seal is we're going to take our pressurized air, usually our bleed air off our turbine engine, we're going to put it in this outside cavity. And in that outside cavity, we're going to put that pressurized air in at a higher pressure than what our oil cavity is. And it's also a higher pressure than what's outside the other side of the sealed. So whether that's a compression area, combustion chamber, whatever that is. So our pressurized air comes in, and we know we're gonna have a little bit of leakage in between where that seal rides. In a perfect world, those don't even touch. They're just very, very, very close to each other. So we're pushing air in, and we're gonna be pushing air through those tiny gaps. That's gonna go with and head out. And on some of them, they even have where they'll allow some air out the top because, well, why send it all through our oil separator if we know it's just air coming in? But the air will also come out the other side of our labyrinth seal. So this one's a little bit different drawing, and it's a 6-minute video. So we're gonna let him explain it, and then we're pretty much towards the end.
Harbor Freight tools keep getting better with time. Better performance, better durability, better value. Whatever you do, do it for less at Harbor Freight.
So here we have this area here. That is a labyrinth type seal. And a labyrinth seal is comprised of a series of fins or knife edges. On initial running of the engine, the fins lightly rub against the lining. So this is the lining here. And it cuts into the lining, giving minimum clearance between the fins and the lining. Pressurized air from the bleed air system bleeds inwards. Okay, so it comes into the pressurized air, comes in here. Let me just change the color. So pressurized air comes in, and then it bleeds across the fins. And as it bleeds across, we get a pressure drop. So we might just look at that more closely. So here are the fins replicated. Here's the bleed air. So when the air comes through and it passes these fins, we get a pressure drop. So we get high pressure here and low pressure here. So that means we have a low pressure area in here and a high pressure area here. And because of that, the oil that comes in from the pressure pump, that's sprayed onto the bearing and sprayed at high pressure. And when the oil hits the hot bearing, we will get an oil mist. And that oil mist will say, well, look, there's a high pressure out here, and we're in a low pressure area, and gases want to go from high pressure to low pressure, not from low pressure to high pressure. So the mist of oil won't be able to go this direction. Okay? It won't be able to seep out past the seal. So the compartment is oil tight. Okay? Now it's not airtight because air has to pass over it, but it is oil tight.
That's all I can take from this guy. So I left him in there if you wanted to review sometime the other thing, but
Carbon, right?
say what?
Carbon.
Not necessarily. So Jay-Z showed sometimes they'll have a carbon out here. It said necessarily, right? Yeah. Sometimes yes, sometimes various materials. But he did make a good point. They call them knife edges. Brand new ones might actually be in contact. When we think of a carbon seal, normally we think that carbon seal is going to ride on a surface, and carbon is pretty hard. You put an oil in between there, but you're going to get a little bit of wear. So don't think of this like a carbon it's going to wear. Think of it more like we want it as tight as possible. So it might be touching when we put it together, but it will leak once we're running. We get the vibrations. It's just we want as small a leak as possible when we're doing it. Okay. What was that? So
Lay on all the bearings, the thrust bearing and the radial.
Yep. Yeah. So they're fairly complicated. My mouse is gone. Oftentimes not gonna be able to see these, right? Because you got a housing around, and then so they're multi-piece, they're complicated. If you ever get to where you're touching bearings on a turbine engine, you're pretty deep into the belly. You're probably not, ain't happening. So mostly you gotta understand what's going on, why we got bleed air, why we have the dry sump. So they're not something you're gonna work on, it's just understanding how the seals work. Why, if we get oil in our combustion chamber, we go, ooh, something must have gone wrong with the seal. Maybe the thing's all wore out, or maybe our bleed air is not keeping up. So we got a restricted bleed air or something. All right, last chance oil filter. Not drawn in here, but JZ did a good job. When I thought last chance oil filter, in my head I was always kind of thinking there'll be a little screen in there, right? If you noticed from his video yesterday, it actually looked like a tap that you were going to tap metal with. And in a tap, you've got the little cutouts every 90 degrees. And basically, when he drew that and showed it to you, in between each cavity on each side of the thread tap, the oil would have to go through. And the idea being, they would drop a last chance oil filter, like right in here. So that's going to be your last chance. And the holes in the last chance are smaller than this little hole here. And if anything makes it through the last chance, it'll make it through the orifice, and hopefully it'll just get sucked out and then filtered out later on. So last chance are usually built in right into that area, maybe this area, and you are not going to touch those things unless it's a pretty heavy maintenance, because they are pretty deep into the belly of the beast. We talked about this previous. When do you add oil? It's typically after shutdown, because our oil tank is sitting back here, and when we shut down, a lot of our components might kind of seep oil. When I say after we shut down, if we're talking hours or days of shutdown, we might seep backwards through some of these components. So we want to know how much oil we have right after we get done running with our dry sump systems. All right, I think this image, might show up somewhere in your near future. So you got the turbine engine here, right? What do you suppose all those red things are? Fuel pumps? Oil pumps. What kind? Give me a little more specific. Scavenge pumps, yeah, because typically we got a bunch of scavenge pumps and one pressure pump. So they're sucking the oil out. They're sucking the oil and air out. It's going to go through, I don't know if I can even read that. That says scavenge filter, heat exchanger into our oil tank. So is that a hot tank or a cold tank? Cold tank, which is our common one. So scavenge pumps through our cooler into our tank, and then we have our pressure pump that is going to be sending oil back out to our bearing assembly. What's this little guy here, do you suppose?
Oil relief valve.
Yeah, like an oil regulator or oil relief valve, yeah. So anyway, that's just a standard little turbine system, and mostly it gets you to go, okay, I know the difference between a scavenge pump and a pressure pump. Like I said, I'm trying to make this last exam pretty easy on you. Here's the Kodiak when they flew into SMAT last year, I think. What do you suppose would be labeled on that right there? Oil, that's what it's got to say, right? That's pretty much all. It doesn't say the type of oil, but up here, somewhere else, a lot of times they'll give you what type of oil. Apparently they're using BP turbine oil. It's not JZ's favorite, but it's oil. And I thought this was kind of fun. We got our air-cooled oil cooler. So air comes in here when you're flying really fast, goes flying through the oil cooler, and then out the side of the aircraft. So that's kind of the main place we're cooling our oil with. How else do we cool our oil on a turbine engine a lot of times? Fuel, yup. This one has, I might have said that backwards. I think that one's got a door to open and close, so we can control how much we cool our oil, but now I'm second guessing myself. We'll see if it shows up in a later one. Alright, one last component I'm supposed to kind of teach you guys, we didn't talk too much about yet, I don't think, is a oil separator, but a cyclone type. We talked once about like the centrifugal kind on where it'll spin and the oil will get thrown to the outside and the air goes out the inside. A cyclone type might look like this. I might have taken that off a refrigeration page, but you know. And the idea is we would have, this says oil, so oil's coming out the bottom. We want liquid oil with no air in it. So we would put in the side of here, we would put our air oil mixture, and basically it just comes in and spins. So out the top of your tornado, if you will, your cyclone, well, it pretty much should be just air, right? There shouldn't be oil, because the oil is going to be in that spinning, and the weight of the oil gets spun to the outside. So basically our air is going to come out the top, and our oil is going to settle down to the bottom. So kind of gives you an idea. Now that one is a standalone. This image shows a whole turbine system with your sumps and stuff, and they done put your cyclone oil separator right inside the oil tank. And they were like, so that's kind of cool. So it might be a standalone outside, it might be inside the oil tank. They do a lot of different things, but questions come up with that. So you got to kind of understand what a cyclone oil separator does and how they work. Here is, I don't know, what is this thing? Is it an oil cooler or is it a fuel heater? All right, so it does both, right? It does a little bit of both. What controls if it's going to transfer? A vernitherm, okay, so in this instance, are they going to look at fuel temperature or oil temperature? Oil temperature. So we got oil inlet goes across the vernitherm and out. So if the vernitherm is hot, if it's expanded, the oil is going to have to go all the way through our heat exchanger and back out. If the oil is cold and our vernitherm is shrunk down, now our oil could just come in and go right back out, and we're not going to be taking any heat off our oil. So there are multiple ways. So is this the one that I don't know the answer. I won't ask that. Is that the one that's on the PT6? I think we control that with fuel, don't we? Fuel temp on the PT6. So we have to look that up. So anyway, there's multiple ways to do it, but that's probably the more common one. Okay. You guys can read that. Oh, why the turbine bearing compared to the other bearings? It's hot. Turbine's hotter than blazes, right? So it's not just the deformation of it, but turbine bearing's hotter than blazes, so that heat's gonna transfer. All right, I did not have this anywhere else. This is our last slide. It's my last presentation slide with you guys. I get choked up. And it's just a one-off kind of thing. So EP stands for extreme pressure. So an EP lubricant, we're in lubricants class. Think grease, right? Now, you're gonna have EP lubricants that range somewhere between a grease and a very, very high viscous oil, depending on where you're at. But kind of think grease. So we're gonna use those EP lubricants usually in our geared areas. So we start saying, okay, how about in the gear case of a PT6 engine up front? They're going to consider that one a EP. Probably they're going to consider whatever oil's up front in there an EP lubricant. But really you just need to know, what's an EP lubricant? Extreme pressure. Something we're going to use typically for wiping friction. Okay, simple enough, right? Okay, I had this, but we're going to save that for Devo's time at 10:50. So you'll get a little piece. My send-off is Mark Lowry.